Welcome back, and here's the last of our 3 units of review of moles, molar mass, and molarity. So the last one we're going to look at is how to use moles, molar mass in molarity calculation. So how do we measure the concentration of a solution? And since a lot of biological systems, buffer systems, the circulatory system with blood, all deal with liquids and solutes and their solutions and concentrations, we need to know a little bit about molarity. So just real quickly, again, molarity, which is the large M, is moles of solute divided by liters of solution. So it can be written in shorthand, big M equals moles over liters. Now, pretty straightforward most of the time. The one thing is sometimes they may not give you moles directly. They may give you grams. And in that case, we've just got to use the molar mass, as we've done the last 2 sections, to convert that to moles so that we can plug it into the equation. So I'm going to go through 3 different examples of problems, each a little bit different than last, each asking something in a little bit different way. Okay? So first one we're going to look at is what is the molarity of a solution when 0.75 moles of NaCl or salt are dissolved in 1.5 liters of solution. So again, we've just kind of set it up. So remember, we're going to have molarity equals moles over liters. So we've just got to look for the right units. So in this case, they give us moles and they give us liters already in the right units. So we can just plug in molarity is going to equal 0.75 moles over 1.5 liters. So 0.75 divided by 1.5, and in this case we get our answer of 0.5 molar. So there's our answer. So that one's very straightforward. That one, they give us the units without having any conversions. So let's look at our second example. So now, how many moles of KMnO4, potassium permanganate, should be used to prepare 2 liters of a 0.25 molar solution. So again, they've changed it up just a little bit. So we've got the same formula, molarity equals moles over liters. So let's look at what they give us in the problem. And what they give us is they give us the volume, they give us liters, but now they give us a molarity. So the one thing that we don't have is the mole. So we can do one of 2 things. We can rearrange this formula right away to solve for moles, in which case it would be liters times molarity equals moles, and plug it in. Or we can just plug in as is and get molarity, excuse me, hang on one second, 0.25 molar equals X moles over 2.00 liters. Now I can use a little bit of algebra. We can multiply both sides by 2 liters. That crosses off on this side, And for our answer, we get 2 times 2.5. We get 0.5 moles equals X. So there's how we did that one. A little bit of a rearrangement, but same formula. And the last example that I'm going to give you doesn't give us moles directly, so it's a little bit different. So this one asks, hang on guys. I don't know what happened there. My Mimeo just went crazy. All right, sorry about that. Here we go. What is the molarity when 30 grams of NaCl are dissolved in 750 milliliters of solution? Okay, so now this one, now they give us grams instead of moles. So the first thing that we're going to have to do is convert that to moles. Now that involves finding the molar mass, which I'm not going to go through. We've run that one before. So the molar mass of NaCl is 58.5 grams. So we've got to go through how many moles equals 30 grams. We know that 58.5 grams equals 1 mole, and that comes out to be 0.51 moles. So now we've got a value that we can plug in for molarity. So molarity equals 0.51 moles. Now the denominator has to be in liters, and they give it to us in milliliters. So we can do a quick dimensional analysis, or if we just remember that there are 1,000 milliliters in a liter, we can go 1, 2, 3 decimal places over, and we get 0.750 liters. And there's our equation, and when we do the math, 0.68 molar. So, other than a little mishap with the board, and we get our answer. And there is how we do molarity problems using molar mass and moles.